Today we're going to apply our ratio relationships to something called special triangles. And when the math people of way back in the day sat there and they did all their relationships, they noticed that when there were certain angles in a triangle, the ratio of the side lengths always simplified to the following scenarios. So you've got two special triangles, and three of them are written here because we're just going to show all these different scenarios. But this is one of the special triangles, and this is the second special triangle. And special triangles just mean that they found when certain angles were used, the same relationships always happened. So there's the 45, 45, 90 triangle, and that's this guy right here. And then there's the 30, 60, 90 triangle. And we have that twice just because we're going to talk about relationships from either the 60 degree as the given angle or the 30 degree as the given angle. That's the only reason that we have it twice. So when you've got a 45, 45, 90 triangle, that means that the theta value of your relationship when you're going around and you're figuring out what either theta or your related acute angle is, you've got a 45. The relationship of the side lengths is opposite and adjacent are a 1-to-1 ratio. They're going to be exactly the same length. And the hypotenuse of your special triangle, your 45, 45, 90 triangle, is square root of 2. Why? Because if we did the Pythagorean theory right now, we would go 1 squared plus 1 squared equals c squared. That's 2 equals c. Square root of 2, square root of 2 equals c. Okay, so that's where that comes from. Then the other triangle that they notice, and you have to kind of commit these to memories. These are something that you've got to memorize, is the 30, 60, 90 triangle. And the way I remember this triangle is if we're going from, we'll go given angle, I'll go 30 first because I like to start with the smallest angle. So if the given angle was 30, the side that is opposite of the given angle is your lowest number. 30 is the lowest number of all the degrees. The side opposite is the smallest number. Okay, so it's a 1, 2, root 3 triangle. So 1 goes across from the 30. And then if you're thinking of 60 as the theta angle, opposite 60 is the second smallest angle. The square, even though the magnitude of 3 is larger than 2, the square root of 3 gives you a number that's 1 point something. So it's bigger than 1, but it's smaller than 2. So the second largest angle, which is or the second largest angle, 60, is across from the second largest side, root 3. And then the longest side on this triangle is a hypotenuse of 2. So commit these to memory. And when we're doing questions that involve these solutions, you're going to see we can solve them without calculators because they're always going to be these relationships. And what was the last thing I was going to say with that? It'll come back later. Okay, so let's look at some of our relationships here. Sine of 45, it's hard for me to scroll. Opposite would be sine, opposite would be 1, base root 2, or hypotenuse is root 2. So if we rationalize that, it would be root 2 over 2. Cos of 45, adjacent, that's 1 over hypotenuse, root 2. Let's rationalize that. Root 2 over 2. Okay. Tan, opposite over adjacent. Woohoo! 1. If you punch those into the calculator, sine of 45 and cos of 45 are going to give you these ugly fractional decimal numbers. But then tan of 45 is 1. And that's because you were taking an opposite and an adjacent, and they were the same number. And when you divide them, they give you 1. So let's look at 60 and our 30. So I did it backwards. One take this, put it right there. Just one take this, put it right there. Okay. So 60, opposite over hypotenuse. Nice. We don't have to rationalize this one. The 45-90 triangle is the only one you'd have to rationalize because the hypotenuse, oh, that's not fair to say. The hypotenuse is here. If we're using our primary trig ratios, if we're using our reciprocal trig ratios, you're going to have to rationalize for the 30, 60, 90 triangle. You probably aren't even making sense of what I'm saying. Okay, opposite. Square root of 3 over hypotenuse. Done. That's the answer. We're not going to convert it into a decimal because that's the exact answer. As soon as we go decimalage, you have to round. You're not making it exact anymore. So cos is adjacent over hypotenuse. Love that. 1 over 2. Hello. Love 1/2. Tan is opposite over adjacent. Root 3 over 1, which simplifies to give you just root 3. So those are our exact values for these relationships. Let's look at our sine of 30 with our 30, 60, 90 triangle. So if our given angle is 30, go opposite over hypotenuse. Now we're getting the same values. They're just switching spaces. Here, cos of 60 was 1/2. Now sine of 30 is 1/2. And these are just relationships that people noticed for years and years and years. Cos adjacent root 3 over 2. Root 3 over 2. Oh, do we have to rationalize tan? Yeah, we do. Opposite over adjacent would be 1 over root 3. But we're not leaving it like that. You'd multiply by root 3 over root 3, so you get root 3 over 3. So we've rationalized that denominator.